we have x being exponential with parameter lambda. And here we're asked to show that the memoryless property can be derived another way by finding the conditional CDF of x given being x given x is larger than c, sorry. And then the conditional PDF of x given the same condition. So first, let's think about what we mean by the memoryless property. So if we look in the Blitzstein book, we see that the memoryless property basically means that the probability of x is larger than some condition c plus t, conditional on x larger than c, is the same thing as probability of x being larger than t. So essentially, having waited for c time, it's the same thing as subtracting off this c and then just starting off from t again. So it's basically starting over again, and this can be written as the probability of, which is the same thing, x being larger than little x, conditioned on that we have waited some time c, and that's the same thing as the probability of large x being x minus c. So it's basically, so again, that we're subtracting off this time that we waited and just start over again. All right, so let's write down the CDF first. I mean, we are asked to derive this whole thing by finding the conditional CDF and then the conditional PDF. I mean, it is basically sufficient to show it by finding the conditional CDF. So what do we have here? We have that f of x conditional on little c is the same thing as the probability of x larger than being so, conditional on this condition we given. That's the same thing as just using base rule here and then writing out the joint event, little x some being larger than c. Now this whole thing is the same as just one event, so x, large X being less than little x but larger than c. Okay, and this, we just take the complement to align it with c, x being, large X being little less than little x. Okay, and now since we have two fixed points, we have c and x, we can take this integral and then we can take this ratio here, divide by 1 minus this ratio here. But we don't have to calculate the whole integral. I mean, we can basically just plug this into the CDF of x. So this is the same thing as if, well, the probability of x minus probability of x being larger than, well, sorry, I'm just going to write it into the PDF directly. I think that's, sorry, the CDF directly, because that's what we are ultimately doing. So we have the, I mean, the whole inequality here is the same thing as taking the CDF of exponential at point x, then minus point C. And this is 1 minus FC. And so these things are now that we just write them out. So write this out. So the CDF is, remember, for the exponential is 1 minus e to the minus lambda x. So for any x. And now we just evaluate these terms. Okay, so we have 1 minus e minus lambda x, and this minus 1 minus lambda c, whoops, like so. And this 1 minus 1 minus, there's a lot of ones here, 1 lambda c. And so we have the ones canceling here, this becoming positive. So we have c minus e to the lambda x, like so. And this, to simplify it a little bit, so we can break out these terms, this will become 1 minus this lambda x. And this is indeed the CDF of the unconditional exponential. So essentially, by conditioning on this event, we have a fresh exponential that we are now starting over from. And the PDF is obviously, as we have done several times, is just the derivative of this fx conditioned on x little c, which is lambda x. Okay, and this event, I should just force in terms of the conditions that we have. Let's see, this holds when c is less than x. If c would be larger than x, then this term would be 0. So essentially we have that this holds for c being less than x. Okay. All right. So moving on to the next piece of this problem, we are now asked to find the conditional CDF of x given x being less than c, and then the conditional PDF of that. So okay, now we're basically just going to write down the whole thing again and think about those relationships again. Okay. So the conditional the probability of x being less than little x, now conditioning on x little c. Okay, so here we use base rule. Probability of X less than C. And then again take the joint event X and C, like so. Now this is the same thing, and we're here again assuming that well, so if basically if C is less than X, then it's the same thing to say that if X happens, then C will automatically happen with probability 1. So we can just drop that event. We have probability of X being less than C. And those are just using the CDF of the exponential 1 minus e to the lambda x divided by 1 minus e to the lambda c. Okay, and that is the CDF of what we've been asked to find. Now, taking, as we did in the previous problem, we have then the PDF of X conditioning on this is the same thing as the derivative of what we have over here. So just copy this, like, whoops, like so. And now we're taking the derivative with respect to X. So this is just a constant. So essentially we can then just treat this as a constant and take the derivative with this, which is basically the PDF of a exponential. So this is the PDF that we have been asked to find, and we have the condition that X is now less than for X less than C, and otherwise it will be 0.